I think I have it on the next slide actually. So anytime you get a new concatenated message, say of size, say you say, oh, there's going to be 10, expect 10 SMSs for this, concatenated message. So it allocates an array of 10 pointers to C++ strings in that case, however many you say there's going to be. And then whenever a new one comes in, or whenever the next one comes in, and you say, okay, here's the next one, it's number 4, right? The first thing it does is it checks to make sure that it's like, oh, did I already get one that's number 4? I.e., is the pointer to a null C++ string, or is it to like one that I already have? And so that's how it knows whether you've already gotten this message, and if you've already gotten it, it just throws it out. Otherwise, it uses this array, and it's great logic. It says, oh, if you send me a 0, I know there's nothing, there's something wrong because I only expect them to be, starting at 1. If you send in one that's too big, it's like, no, you're trying to do something evil. You're saying too big, it kicks it out. But the problem is, if you send in one without enough data, then you get this number of -1 because that function, is indicating there's an error. And then it's like, oh, the -1 spot in the array. Cool, I'll go there. And then, bad things happen. So that's the bug, is you can access a pointer before an actual allocated array on the heap. All right, so then what happens? Like I said, so what's it do with this value that isn't really in your array that it's looking at? And what it does is it says, I'd like to compare this to see if it's a null string. And it's not a C string, so it's a C++ string. It's a structure. So what it does is it compares, and in the structure there's things like links, and the actual data, of course, and like reference numbers and stuff like that. And so it compares it to see if it's the null string, which means it has length 0. Okay, so and we want to do things as an attacker, right? So we want this thing to end up pointing to something that it's going to think is a null string, so that it'll keep processing. Because otherwise, I said, it just throws it away, and we don't want it to do that. So the way you have to do that is you have to have a length of 0. And so that means wherever you're pointing this thing to, so it's going to be just some random value on the heap. But if you suppose you have control of that, you want to point it at something that has a 0 somewhere, a 0 D word. And that way, when it goes to do this compare, it'll say, oh, yeah, it's a null C++ string. Let's keep going. All right, so then the next thing it does, once it says, okay, this is a null string, now what am I going to do with this data that someone just sent me? It tries to assign that data to that C++ string. And the way it does that is first it does this function called exchange and add, which basically turns out to do so the first thing it's trying to do is get rid of the null C++ string and basically replace it with a C++ string of the data that you've sent it. So the first thing it does is exchange and add, which basically does a decrement of the reference counter of the string. And then it calls destroy, which is like free. So that's what it does. All right, and this is what it is in words, what I just said. So you want to replace the old string with the new string. So what it does is it adjusts the links, which isn't important. And then it wants to get rid of the old string, which it does by decrementing a value from this structure, and then it frees the buffer. And again, remember, this is going to be some value that it shouldn't be messing with. So what do we need to do? We need to make sure that we control this value that happens to lay in the heap right before our buffer. And then we want to make sure that it points at something that has a 0 D word. And if all those things happen, then what we get out of it is we can decrement something and we can free something. And it turns out that either of those two things is enough to completely take over the process in theory. But the problem is, like if I'm attacking IE or Safari or something, I have a lot of control. I can run JavaScript, I can have it download images and all sorts of crazy stuff, right? But here, all I can do is send SMS messages, right? So the question is, just by sending SMS messages, is that enough that I can arrange things to make all these things happen? And I wouldn't be here if I couldn't. So yes is the answer. So how do you do it? Well, let's think more about concatenated messages, because that's the key to everything here. Every time there's a new reference number, I already explained there's this array of strings that's allocated. That's fine. So we already talked about that. And also, when new data comes in, obviously that string has to be stored somewhere. So that's another place where things are allocated. And finally, when the concatenated message is done, so maybe you have like 7 of these messages, well, it wants to show it to you on your phone. So it concatenates them all together into one big string, shows it to you, and then frees it. So that's what else is done. So these are the 3 things we can do. We can allocate buffers of size 144. That's the C++ pointer things. And then we can, oh wait, that's the second thing. So first the first bullet is the data from each of the messages. The second one is the array of pointers to strings. Each of those guys we control when they're allocated and when they're freed, because if we don't ever complete the message, it never actually frees them. And then the last thing is we can create one big old monster long string, but it doesn't stick around for long. That's all we have at our disposal, but that's enough to completely massage the heap to do exactly what we want. All right, so actually kind of running out of time, so I'll just go sort of a little quick, and if you can't get it, then catch me tonight or something, and I'll explain it to you, or watch my longer talk. So the question is, what do I want to decrement, right? And it turns out that you need to know a little bit about the way the heap works on OS X, and the way it does it is, for different size buffers, it keeps a list of all the freed pointers, and then whenever you go to malloc something, it grabs something, if there's something already of that size in the free pointer, it just gives you that. It just recycles it. And if there isn't one exactly that size, it takes a bigger one, if there is one, and gives you, that portion of the big one that you asked for, and then it splits it, and the little one it puts back on the freed pointer list in a littler slot. That's all you need to know as far as memory management goes. Okay, so then what can you start to do as far as manipulating the way the heap's laid out just by saying SMS messages? Well, one thing you can do, and I already sort of alluded to this, is you could send a different, like a long concatenated message. Say you're like, okay, expect a concatenated message of 100 SMSs. But if you only send 99 of them, they'll all be in memory, but it can't free them because it wants to concatenate them at the end, and it hasn't ever gotten the 100th message. So in that case, each of these messages can have 140 bytes, and then you end up with, 0x90 byte buffer, and you can send up to 254 messages, and each one of those, and then there's different reference numbers too, so there's 255 different possibilities there too. So you end up with filling up 9 megabytes of the heap. You can massage out your data. And if you use 16-bit reference numbers, you can get 2 gigabytes of the heap. So you can fill a lot of the heap with this stuff. So you can do a heap spray, even though you can only send 140 bytes at once. And like the last bullet says, the best thing is you can be doing this, and the user never knows it, because until you complete a concatenated message, it never gets displayed. So they have no idea this is going on. And this is what it looks like in a debugger. So I'm sending in 3 different messages. Well, this one's the first one, the second one, the third one. And then in memory, I see my stuff laid out nicely. All right. And then also you can do other more complicated things, like instead of just trying to lay it all out right in a row, you can try to create holes, which is going to be important because we want to control things before the buffer, right? And so the only way you can do that is to have something already there and have your thing end up right after it. So the way you do that is you can do like reference 1, this one, reference 2, this one, reference 1, this 2. So you end up with 2 reference numbers and you intertwine them, then you complete one of them. And so one of them gets freed, but they're every other buffer. And so then you end up with all these holes in the heap. And this is what it looks like when I start to do the attack. So the thing that's in blue is the buffer of C++ pointers. And that's the thing that I can allocate, or I can access before, because it does a -1. That's what it's pointing to -2. And the way I did that was I created a bunch of holes. And then when I did allocate the C++ strings buffer, it ended up in one of those holes, and so I controlled the thing right in front of it. And so here, when it tries to do the compare, it accesses that 414141 pointer thinking it's a C++ string, and it dies. So I'm on the right track. All right, so I can now, if I would have laid out my data better, I could have started to do things like decrementing and freeing things. But what do I want to decrement? Well, one thing you can do is look at a pointer on the freed list. So if I could decrement, if there was a pointer on the free list and I controlled the data before that pointer, I can start decrementing that thing, and then it's no longer actually pointing to like heap metadata anymore. Now it's pointing to my data. And then when it does the unlinking, this is like the old attack from like 5 years ago on heaps, you get a write for primitive out of it. So that's what I do. And the other advantage is that the freed list in Mac OS X is always at the same exact address. There's no randomization. So I know right where to look. All right, so this is everything that I want to do to take control. It's a lot, right? And the question is, is it possible? So I want to make sure I control the data right before an array of C++ strings, which I'm going to underflow. I want to make sure I have data right before a pointer on the freed list, so that when I decrement it, it points into my stuff. Then I want to actually do the decrementing of it, and so it points into my stuff. And then I want to do an allocation so that it gets unlinked. And then